All right, example 3-ish with trig integration. So let's say I have sine squared of x dx. Looks very similar to a lot of the ones we've done before. Our problem is we don't have the derivative sitting here. Like it's not, I can't do sine of x is equal to u. That's not u squared because the derivative of sine is cosine, and there's no cosine up here. So du is not up here. So that's our problem. And before, when we had sine squared, we changed it, and we said, oh, sine squared is equal to 1 minus cosine squared. So we did that. Don't take notes on this right now. Just listen. But the problem now is, now we have the same problem with cosine. I can't do u substitution there because the derivative of cosine is sine, and it's not up there. Okay, so I have to go to another method. We were on the right track when we said we would use one of those trig identities to substitute. But I don't want one that just changes it to another squared term. So if you have your list of trig identities, look for one involving sine squared that doesn't give you another trig expression squared. And you will get to your half angle identities. There's one that says if you have the sine squared of, it depends on what you're looking at. A lot of times they use theta with their trig identities. That's equal to 1 minus the cosine of 2 times whatever the angle was over 2. Or sometimes you'll see it as 1/2 times 1 minus cosine of 2 theta. They mean the same thing. So we're going to use that identity here. So instead of sine squared of x, we're going to change that to, I'm going to use the second one because I'm going to take that 1/2 out. 1/2 times 1 minus the cosine of 2 times the angle, which is 2x in this case, dx. The 1/2 is a coefficient, so I'm going to bring it out. Remember, when you're bringing stuff out, you can only bring coefficients out, numbers out. You can't bring variables out. And you can only do it if you're multiplying, which I am here. So I have 1 minus the cosine of 2x dx. And now I have something I can take the derivative of. Antiderivative of 1. Oops, I don't want that symbol anymore. That just gives me x. If I integrate cosine of 2x, actually I have negative cosine. Antiderivative is sine. But if I end up with negative cosine, it means I must have started with negative sine. Now you can't change the angle. The angle is 2x. It's got to stay 2x. But remember, when you're doing antiderivatives, you have to divide by the derivative of that angle. The angle's 2x. Derivative would be 2. So don't forget that little piece. So that gives you 1/2 x minus the sine of 2x over 4 plus c. And there you go.